Hello everyone, welcome to the last talk today, 6 o'clock Saturday. First, a word from our sponsor. Sponsoring the Los Angeles Bee Ballroom here is MaxCDN. MaxCDN is a next-generation content delivery network based in Los Angeles. The whole team is obsessed with speed, automation, real-time reports, and implementation. So if you want to put some of their bandwidth through their CDN, head over to maxcdn.com for a free trial. The 6 o'clock talk is Jason Brooks, solving NP hard scheduling problems with oVirt, and is that OptaPlanner?
OptaPlanner.
OptaPlanner, yep. Oh, and if you look on the back of your registration cards, there's a link to the speaker survey. We'd appreciate that. If you find a moment, go ahead and log on and tell us your thoughts. Thanks.
All right, thank you. All right, cool. So let me start out by saying that I'm not a math pro, not a math guy. So I may, if I mischaracterize things, correct me. I was just, these are MP whatever, hard, complete, etc. sorts of problems that you're getting at with OptaPlanner. But I was meaning that to be enticing for people to, come in and tell me why I'm wrong, or can you really solve them, or things like that. So anyway. Please, just correct me, and I'll repeat your correction for the video, so that we can have it for posterity. So my name is Jason Brooks. I work for Red Hat in the our Open Source and Standards Department, where we just we work with the upstream projects that we depend on, and that's a lot of fun. And let's see. Oops. All right. So we'll start off with oVirt, right? oVirt is a virtualization management project solution. It's the upstream for Red Hat Enterprise Virtualization product. It basically is like in the same space as vSphere. Red Hat also is loves OpenStack and works on OpenStack. It's kind of, if you are more traditional Virt leaning, oVirt is your bag, and if you're more, cloud leaning, then you're probably going to be happier with OpenStack, or RDO is our distro of that. Every product of this type or project of this type, has these basic scheduling problems that that it has to deal with, and this is the same with OpenStack or any kind of virtualization management deal where you got multiple hosts and you got to have resources and you need to place them. When you run a new VM, where does that VM show up? When you're live migrating to take a host down and you put your host into maintenance mode, where do those VMs go? There's different oVirt supports like I want my VMs to be balanced to maximize power savings, so I can bring one host down and really load up the other hosts that are up. Or you can say I want it all spread out so that we have maximal resources available to the VMs. So there are all these things that are happening, and there's some sort of scheduling logic going on in any kind of piece of software like this to sort of decide what happens. And then this is just, I just grabbed these out of the slide deck. I mean, these are the things. You have an HA deal, your host goes down, the VMs need to be restarted somewhere. Where do they get restarted? I mentioned the balancing, for, it could be time of day, it could be, other factors that you want to specify to control where your hosts show up, power savings, things like that. So how scheduling is in oVirt right now, and in fact, and this is without the optimizer bit, has these sort of, it has a filter stage where hosts are just knocked out of consideration for these failing hard constraints, like there's not enough RAM to run this VM. So in deciding which host to send to this, to send the VM to, there's not enough RAM, so host is it's filtered out. And then there are weights, and this is sort of a soft constraint sort of a thing. Well, all right, this set of hosts have enough RAM to run the VM that we want to run, but this one is more congested or less congested than another, and so we wait to say, well, of the nice-to-have things, which satisfies the most nice-to-have constraints. Then there are these balancing things where these I think it's once per minute or something like that, a task can go and say, now, based on the state of how things are, can we move things around? How might we move things around to satisfy the desires of that the admin has set up? And so, and this is kind of how some of this looks in a cluster policy. There's various elements that you can select for your filter items, for your weight items, and then your balancers there. And there's also in oVirt, there's an external scheduler that allows you to just sort of write additional sorts of rules to decide where things show up, and you can write them in different languages. You can sort of the way it's set up is the engine itself, the management engine for oVirt, can kind of be protected from the code that's written, perhaps the external code, and that's now the optimizer. This optimizer project comes in where beyond those sorts of those scheduling, the filters and the weights and balancing items, and the ability to extend it. There's more that's kind of there are situations that aren't automatically solved by those things. You can have a better configuration of VMs across your cluster if you had more information, or if you could look into the future to know that what the ramifications would be of starting a set of VMs in a certain order, or what else is going to be happening in the environment. And so but in order to do that, in order to add these additional optimizations, it's important to the project to keep the compatibility with the existing sorts of these weights and filters and whatnot that the admin has set up. It was also one of the goals of this project to the oVirt management engine is a JBoss application. And as additional things have been added on, or additional functionality, the project has tended to implement these things, make these items implementable in a separate. You can run them on separate servers, or you can kind of coordinate off from the main engine, so that you can control the sort of load, extra load you're putting on the engine. So the scheduler that I mentioned, the external scheduler thing, you can run that in a separate machine. There's a data warehouse element that just collects information about what's happening in your environment, and again, that's the same type of model where you could run that on the same hardware as your engine, or you could run it separately. So they want to do the same thing with this optimizer. And this is a kind of a simple situation that, like, this is something that you can get with the current scheduling scheme, where there is enough room. Like, you could have these three VMs, AVC, smaller VMs, and D could be accommodated if only you moved A down to with B and C, and you'd have a whole host open for D. That's a very simple sort of a pattern that is easy to just see and recognize, but especially at large scales, it can be difficult to figure out where to pack these bins, or how to pack these bins, if you will. And this is a machine reassignment problem. So this is a big problem, and this is do I have it on this slide? So I'll wait a second for that. So you've got a set of machines, and you have a set of processes, and each one has some resources that need to be provided for it. Those are the hard constraints. This process requires this much CPU, this much RAM, and the processes in the oVirt case are the virtual machines, right? And then this is where I'd say is this an MT complete thing? I'm not getting I'm not confident in my full grasp of the details of this, but it's basically a sort of a problem where given a solution, you can verify that yes, okay, this is a solution to the problem, but how do you find this asterisk here, defining the optimal solution of the problem, if you can figure out the algorithm to figure out the solution to a problem of this sort? I think it's like $1 million prize is waiting for you, and fame and fortune and whatnot. But a lot of people think that there just is no way to come up with an optimal solution to a problem like this in a reasonable amount of time, and something that you could actually do with computers. And so there's a cool on the OptaPlanner project site. There's a blog post that's basically kind of looking at, well, how big really are these problems, and just doing some kind of basic calculations for different sorts of these problems, and the space that of possible solutions is enormous. And as the problem grows, as you have, for instance, in these machine assignment cases, more processes, more hosts, it just completely explodes quickly. And in particular for this sort of the VM optimal VM assignment problem, it's hard to even when you can pare down the space, you can say, all right, I can programmatically understand that huge swaths of the space are automatically will not produce a solution. It's still a huge problem, and it's difficult to pare down to programmatically say, cut out these swaths with the cloud balancing problem. So this is what OptaPlanner. This is the sort of thing that OptaPlanner is intended to do. Take these problems that are too big to solve in programmatically and probabilistically attack the problems. Come up with a random solution, and then come up with another solution, and then was the second solution better than the first? If so, okay, keep it and move on. If not, go on to the next one. And there are different algorithms to how you conduct that search that can give you different results. And I'll give you a little look. The OptaPlanner project has a real cool demo application to show you some of these things. And so this is like this traveling salesman is one of the problems, and this is kind of a cool looking, that's kind of a graphical example here. It's cranking through. It is measuring, based on the constraints of the problem, it's measuring what's going to save you the most fuel, and it'll go through. And then you can see here, terminate. They have some of these things where there are some of these different algorithms that are pre-calculated. So the first fit algorithm, just a completely random one. And there are these taboo search where solutions that don't work are you don't return back to those solutions as you are traveling around. And it also, compared to some of the other algorithms, there's a tendency or possibility to get stuck at a plateau of solutions where you have a set of scores that are all very similar to each other, and only if you jumped to another area of the space, there could be a much better solution, but you can, with some algorithms, get stuck like in a particular neighborhood of solutions. And so this taboo search is what this particular integration with oVirt uses. And then we can just take a quick look here at, they actually have a machine reassignment example in here, and you can let's see, and this is the same sort of problem that we're talking about here. You have a certain number of processes, you have a certain number of machines, and OptaPlanner cranks through them, looking for things that satisfy the hard constraints, and then what's the optimal I don't know, satisfaction of the soft constraints, I guess. So that's a fun thing to play with and get a little bit of a handle on what OptaPlanner does. And OptaPlanner is pretty open-ended sort of a thing, where it includes tools to sort of work through your solution and you program it in Java. And it was something that I first heard about it a couple years ago, and I thought, wow, I bet this could really propel me to fantasy sports, greatness, just through finding those perfect trades. And I sat down and on holiday break at some point, and then I said, no, I'm gonna go have a beer. But when this integration came along with oVirt, which is I use every day for testing and testing the stuff I write and how-tos and whatnot, and I said, this is perfect. This is a good opportunity for me to check this out a little bit. So this is some of the stuff I talked about this probabilistic approach. Generate a solution, see if you can find a better one, and then come up with some of these. And there are many algorithms that can, for certain circumstances, give you a better result or faster time to a good result, I guess. All right, so OptaPlanner and oVirt. This is from one of the other OptaPlanner and oVirt decks. I guess it's really not that helpful of a picture. It just is. I guess all it's showing us is that the oVirt optimizer is implemented in a separate box, but there it is. So, how OptaPlanner and oVirt work together? You have oVirt's these policy units. Within oVirt, on the earlier slide, I was showing how much RAM is there, how much CPU, the hard constraints and the soft constraints that an administrator can use in their scheduling. Those need to be converted to these rule language based rules, and rules is a project, is a separate project that OptaPlanner sort of is bolted onto. OptaPlanner uses this rules engine in its figuring out of solutions. So those are those oVirt policy units need to be converted to those DRL-based rules. And then one thing about that is that they're not all yet available through the API. So some of the things, like I have here, this hosted engine score filters, I believe the last release of oVirt, the project added the feature where oVirt can host its own management server. And it's a little bit of a chicken and egg, issue initially, getting it started. And the oVirt hosts that you have set up to be to participate in hosting the engine, they have scoring to decide which is the best host to run to host its own engine on, and that's one of the things that's not taken into account currently in the optimizer. And then this CPU load-based filtering, that's another balancing. That's another item that is not yet. And some of these things, I believe it's a matter of what is available through the API, and some of it is just more work that has to be done. This is actually this oVirt 3.5 came out 4 months ago maybe, and this feature was new with that. And I believe it's in the Red Hat Enterprise Virtualization that just came out, but as a tech preview feature. So that's kind of the stage of maturity that it's at. But yeah, this other stuff is basically the same as. So one of the issues that we have to consider, that we need to consider with the optimizer is that, and this is what this graphic is laying out, because you can't just remove all the VMs, stick them in an imaginary space or some kind of bag of holding or something, and then pour them out in an optimal space. They have to move in. They have to be somewhere at each stage of the process of moving them around to reach an optimal solution. So this is something that the developers in the development of this feature, they have to take one migration stage at a time. Because the VMs all have to be somewhere. You can't just say, "Oh, I'm going to get to now. I'm going to get to whatever the second state, which it is exactly the same as the first state." I think that's by first moving something off into the ether. So that'll be a little clearer. I'll show a couple screens. So in the way that the admin interacts with this at this point is oVirt has this UI plugin functionality where people have done a lot of cool things with it, where you can, like someone has written a web-based shell web UI extension where you can access the shell of VMs that are running through your oVirt web console, or someone has done one where you've brought in the Nagios dashboard, and there have been a few other things like that where that UI plugin functionality has been used to bring in other projects, and that's what the team used for this, where this pane down here is this information is coming from the optimizer service. Okay, so let me see if I can get this to work. So I was trying to recreate this demo of this graphic that I showed earlier, where you have the like 3 small VMs, and then you have the large VM, and if only you put the 3 VMs together on one machine, you'd have room for the large one on the second machine. But and that's just a real simple example of an optimization problem. But I was having a hard time making it work. I think because because this is all running right here on my laptop, I was using the Ceros images that you kind of start out with when you're using OpenStack, or these like 12 megabyte images. But I think that oVirt was having a hard time correctly identifying the RAM usage in those, and it was affecting I was able to get to here, where you can see I had 2 small VMs running on the first host, 1 small VM running on the second, and then when I go, this is the screen that I wanted to see. When I go to launch my big VM, it tells me, sorry, can't do it, there's no room. And I don't know, is that crazily too small? Does this work in this case? No. And it's saying, sorry, there's no room on a host to run that VM. And then you can go over to the optimizer, and it gives you a solution where it says, all right, you can do it by first migrating one of the smaller hosts to the second, one of the smaller VMs to the second host, and then you'll be able to start your big one. But when I actually went to do it, it was incorrectly identifying I think the amount of free memory. And so I thought, well, maybe if I quickly, 45 minutes before my talk, set up some CentOS VMs that, and I can run the guest agent in them, because maybe that will give me the result I need. So I'm going to actually try this for the first time right here. This part of it. So it's had enough RAM. I need to let me just try this real quick, and then I'll give up. I was actually running into more problems with this than I thought, because there are several ways that oVirt allows you to overcommit memory, and I was having a hard time running out of RAM. Let's see. Let me just bump this out to 400. actually. But all right, good. This is the first step that I was looking for. Sorry, can't do it. Now I'll show you. This will actually be good because we'll at least get to see what the optimizer looks like. It's here in this tab down here. And get more space. So now I'm talking to my optimizer, which I'll switch over where I have it running. I have it running in a container, actually. And you can see it. You can see in the logs it's cranking along. The these are all configurable, all these values, but every I think 2 minutes it refreshes the current state of the cluster, and then it is constantly looking at a more optimal solution. Oh, I forgot to do one thing here. This is what it looks like in here, but what I missed was instead of trying to start it just by saying start, there's this optimize start option. And so now that specifically tells the optimizer, we are trying to start this VM. Can you figure out a way to do it? And let's see. So the VM we're trying to start is this foo4 here, and it's giving me. Now this is, I would call, a less than optimal solution where it's suggesting, was it suggesting that I migrate VMs? Yeah. Wonder how long it would take for this to, let me see what it's So it's cranking along here, trying to come up with a better score. Because I'm assuming that it can do a better job than telling me to move 2 VMs to, because really it should be able to do this in only 2 moves. Move 1, what I'm looking for is for it to go from 1 to 2. I might be a little underpowered here in my all laptop configuration. Oh. Excuse me? What goes into the score? Well, what it's taking into account are the constraints. When I showed that early slide where oVirt has these hard constraints that are there has to be enough RAM, there has to be enough CPU, there has to be enough the basics that it needs, and then any results like the cluster right now. Let's see if I have the. For the VM and also the requirements that you set up for your cluster. This is how I want my cluster to run. So I want to spread it out, or I want to consolidate. It's also taking those into account as soft constraints. So it's making sure that all the hard constraints are met, which is just the basics, having enough RAM and CPU, and then it's trying to come up with the best solution that satisfies most of those soft constraints as well. I'm curious to see if it is. All right, let's try to see if we do all this stuff.
You have power management within a post?
I
need another host to spin them up.
Yeah, you can. Well, you definitely can. Yeah, you can, because you can. Like one of the examples that I've seen is that you can set hours that you want your host to be active, or most active, and there's definitely power management for fencing for sure, but you can use that power management also in your balancing and your rules for how your cluster runs. So that's migrating. Let's see if this is migrated. God, I hate this trackpad. Anyone have the new Lenovo? Okay. Now it's saying there's hard constraint violations. Well, this is now my hosts are down. Well, this is some fun, demo theater with a little bit of car crashes, but Yeah. So I don't know if that is going to sort itself out. I have everything running on this laptop in VMs and in with libvirt, but the idea is it gives you the steps that you can follow to reach the end state that you're looking for, and this is some of the things that looking ahead. The optimizer right now is kind of providing guidance to the administrator, and the admin would then carry out the steps. But the project is looking ahead at making the optimizer just the default scheduler in oVirt. So these things would be happening automatically. Also, the policy units that I mentioned that are not fully supported, they're working to further support those. And I didn't mention it before, but that external scheduler where you're writing your own rules, that's also something that's not yet being taken into account by the optimizer. And they are looking, at what potential for cooperation there is with this. OpenStack Gantt is a scheduler project in OpenStack, and then Kubernetes and Mesos. There's possibilities to interact with those projects from a scheduling front, but these are things that these are sort of long-term things, not right around the corner on those. I don't know. I actually first heard about it while I was just putting this together. I don't think it's even at it's at I don't know what stage of maturity it is. Does anyone else here know about the state of the OpenStack Gantt? Yeah, I don't know. I mean, it's one of the million components that are under construction for OpenStack. But does anyone have any questions about this or about oVirt in general? Well, that was a constraint that I was trying to force. Well, there are a bunch of different things sort of in play with this. Like first, these are running as VMs on my laptop, and so the machines that are running here are contained in that way. So now each of the VMs has kernel same page merging, which tries to take the shared or the memory that's duplicated and share it to allow you to overcommit. I turned that off, but oVirt has, and also there are options for different levels of overcommit that you're willing to you can do no overcommit. You can do up to 150% overcommit or 200%. That's something that I also turned off. I don't actually this example of running out of RAM, and so forcing the optimizer to help you out is something that I thought would be a little easier to force. But there are there are various elements in it because also when you give RAM to VMs and oVirt doesn't. Well, again, this might have had to do with the Ceros VMs as well, because it wasn't like with the CentOS VMs. You get a What's that?
You're gonna have to blow it all away. We got those questions.
Oh, do I have them now? Well, this is designed to blow away. Do these ones have question marks now? Oh yeah, because my host went down. That's right. Yeah. So live demo. But some people will just show you screenshots from the beginning, not even try to. No, this would be a lot cooler if it worked just right. But obviously now. Yeah, they're in well, this is they're like, I don't know where to find it. I mean, it's in here. It's but yeah, you know what? Yeah, they're the same. It's the let's see. There's a blog post that was on our community blog by the developer, or one of the developers of the feature, and that has some more information. Do I have internet right here? And I think he has a couple of snippets of the DRL. It's hard not complete. Okay. Okay. So how to solve NP complete? When you once you find the optimal solution, what's the optimal way to shut down and move machines that might be okay. Which is a different problem. A different problem than this?
Yeah, you said you have two problems. One of which is the optimal packing, which is NP hard, which is what you had in your title.
Okay.
I think. Yeah. And then there's NP complete, which is how to migrate from system A to system B, how to migrate there.
Okay. All right. Okay. All right. Thank you. Yeah. That is the sort of thing that I was talking about when I first started. Yeah. 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 No. Yeah. I'm bulletproof. This is a snippet of a hard constraint here from the and this is in this rules language. Yeah, I mean, like I said, I have not yet converted this to fantasy sports Dominion, and I don't know if I'm any closer to that goal.
So is the OptaPlan its own project, or is it
yes.
a subset of oVirt?
No, it is its own project. It is under the big umbrella of JBoss projects, and OptaPlanner is this optimization project, and it is very closely tied to this rules project, which is business rule processing project, and so those are totally separate. They have a commonality of both being Java project, or the oVirt engine is a Java project and runs on JBoss, and so do OptaPlanner and Drools. But it's just sort of a point of those projects coming together and doing something sort of cool. Without the optimizer, it's using these filters and weights and balancers. Oh, yeah, that I mentioned from the beginning. That is, and in fact, they have adopted some of the practices of Nova, actually, from the OpenStack project. It was just about a year and a half ago. oVirt was I believe didn't include the balancing feature or element to it, and they've added that, and they're now adding this. The optimizer is really, it's sort of an advisor at this point, where it will give the admin a example, or pointers for a solution, and the next step will be to roll that in, to this process, as well.
What I read on the internet, but some guy was, I think it was Captain KV, or it was you. He was saying that oVirt might be pulled into OpenStack.
Well, I don't.
Have you heard anything about that?
Well, there's a lot of work underway, and there are things that are already built in to integrate or make points of integration, but there's no there's no clear way to do that. There's certain things that could happen. Like, for instance, right now what is happening as far as the integration is there are two main elements. There is the glance image server in OpenStack. You can pull images out of that into oVirt right now, and that's something that is in the project, and it's been in for a few releases, and it's in the commercial product too. And and a somewhat cooler thing, I think, is that the OpenStack's Neutron networking element, you can take the networks that you've created in Neutron and you can use them with your VMs in oVirt, and that has been in the project also for a couple releases. So those are two things. I mean, I've heard things. Another possibility would be so the images in OpenStack, you use those as oVirt templates, but there's also there's Cinder in OpenStack, which is the disks, and there's talk of including an integration where you can use Cinder hosted disks with your VMs in oVirt. But for them to be completely, or for oVirt to be pulled in, it would be they're assembled really differently, the two projects. It's kind of like it would be more likely to see something like how vSphere integrates with OpenStack, which is just Nova just talks to vCenter and says, okay, host these VMs, and there's a lot of it's sort of a black box. OpenStack doesn't have a lot of information about exactly what's happening inside the vSphere cluster, and if oVirt were to participate in compute with OpenStack, it would probably be something like that. But I don't think that's not something that I think there's been some proof of concept stuff, but I don't think that's something that is under like heavy consideration. It's more of these things. Like the Neutron element in OpenStack, oVirt didn't already have something like that. So some of these areas where there's a chance to extend the project or add new functionality to the project by reusing some things that OpenStack is already doing, that's the sort of integration you'll see, and we are seeing. Yeah, well, that is the way that it works, but it was a matter of what I was trying to do is sort of force this example of like, I can't start this VM because there's not enough resources, and then the optimizer is coming to the rescue. But I needed to do more work to actually make that scenario work in a demo. Mm-hmm. And that would be a place where I think that I mentioned briefly this desktop warehouse or desktop warehouse data warehouse element in oVirt, where it is just collecting this historical information. That would be perhaps an opportunity where the optimizer could talk to the engine, the oVirt engine, to get the current state of what's happening in the cluster, and then could talk to this data warehouse element to get historical information. I mean, that would be a cool direction to take it. Right now, how it's working is it's basing its advice to the administrator based on the current state of the cluster. But yeah, that would be. What was that? Yeah, no, that would be interesting as well. Any other questions? All right. Well, thank you for your attention, your patience, and I hope you guys have a good rest of your evening if you're going to be staying here and tomorrow. Thank you.